Welcome everyone. My name is Christian Hitzelberger. I'm a PhD student at Texas A&M. So I'm going to take you through the first part of this workshop. I'm going to cover some basics, how to do Anova, a quick and easy biplot, and then introduce you to ggplot2 so you can graph some of your data. So start off with some R basics. Know that R is case sensitive, so uppercase A versus lowercase a, that's pretty easy to tell. But some letters like C, it's kind of hard to tell. And if you have an uppercase C, you're going to get an error, so just be careful of that. You separate commands on a new line or using a semicolon. You can use Control-1 to jump to the source editor, which is here, or Control-2 to jump to the console instead of having to click. So Control-1 takes you there, Control-2 brings you down to the console, Control-1 again brings my cursor up there. You can also use 4 hash marks to organize sections. So you see 4 hash marks are basic. That creates different areas of your code to help you organize things. So obviously when you type your code, you're going to need to run things. So you can use this run button here. You can run the current line or a selection, and it shows you. You can use Control Enter. And then also, very important thing is setting your working directory. So that's where the files you'll import and the files you'll export will go to. So the easiest way is through session, set working directory, choose directory so you can select a path. The shortcut is Control-Shift-H. If you already know the path, you can use set working directory and type your path there. If you want to check your working directory, you could type git wd, and that will show you where your working directory is. I'm just using the desktop for this workshop, but you'll want a specific folder so you can store your data and whatnot. So for those that aren't familiar with R, I encourage you to check out the swirl package. It teaches you how to use R within R, which is really great. So to do that, you need to install swirl. This is the same way you install any package in R, with the install.packages function, and you'll type the package you want in quotations and you'll run that. It'll install, and then you'll pull that into your library using the library function. So what the library function does is it basically uploads your package into R so that you can use that package. So what it's actually doing is checking the boxes in here. So you have all these packages that are available to you. Most of these I've downloaded. A lot of these come with R. You can check these boxes, or you can use library. Library is pretty easy, so you know what you've done. You have that protocol coded out. So here, for swirl specifically, this is how you open it, and you'll sign in. So you just type something, make sure it's something you remember, because this is kind of how you sign in to the program per se. It gives you some instructions how to use it, and then within there's about 15, well there are 15 lessons to teach you how to use R, base graphics, all the way to the basic. So I definitely encourage you to use this if you need some help with R. So now we're going to move on to the Anova. So there's many ways to do Anova in R. Here I'm just going to show you using GGE and Agricola. So you'll install these packages. I already have all these installed. And then this third package here, read Excel, is how I'm going to read in my data. You can use read table, which comes with R. But I use read Excel because most of the time my yield data or any other data I have is coming in on an Excel table. So read Excel package makes it really easy to pull in an Excel table. If you don't have an Excel table, it's probably easier to use the read table function. So what is the read table function? So if you want to find out about a function, just type question mark in front of that function, and run, and it'll bring up that documentation. So you can see here, read table gives you the arguments, and there's also wrappers for read table to make it a little easier to bring in more specific files. So we're going to load in our packages using the library function. You see there's no errors. They load in just fine. That's good. Next, we're going to pull in our data. So I've simulated some yield data, just a small little data set. I'm going to bring it in as yield data, save it as yield data, using readxlsx function from the readxl package. So I'll do that. See, it's over here. We can give that a look. We've got 4 columns, 45 rows. We have genotype, environment, repetition, and Y. So let's say we want to change the column names to make it a little easier to code down the line. We'll do that here. We want to change that to gen, environment, rep, yield, shorthand, and expand the yield name. So we go back to our yield data. We can see that these have changed. So you can also check entries by using head. This is going to bring up the first 6 entries and the columns. If you want more than 6, you can use head and then type a number after your data. This is going to bring the first 12 entries up. You can also do the same thing with the end of your data. Use tail. These are really good functions to check out kind of what your data looks like. You should always check your data before you do things. So now we'll move on to Anova. So we're going to use the AOV function. So we'll pull up that documentation. So the AOV function fits an analysis of variance model. You see our arguments here, more specifically here. So I'm going to save the function as Anova. So I want to estimate yield given, so at this line, genotype plus the interaction of environment and rep plus environment by genotype. And the data I want to use is our yield data, or the stuff I pulled in. So I'll run this. You can see we have now Anova over here. And we can type summary. And that gives us our Anova table. Also click view Anova. So this is a S3 object. It has many other kind of tables and things within it. So if we go back actually to that Anova, you see our coefficients are here. We've got residuals. You can actually call those individually. So remember that within Anova, our first line was the coefficients. So we can do Anova bracket 1, and that pulls our coefficients. So if you need to save things out of that object, you can do it that way. So now we can run coefficient of variance using cv.model. In our model, we saved as Anova. So run that. You see our CVs over here. You can check it by just looking over here, or we can highlight CV, which is what we've saved that as. Run that, and it shows here in the console. We can also run an LSD test using LSD test function, $LSD to pull up that documentation of the function. You can see it's in the Agricola package. See usage arguments of this package. So here we'll test genotypes. So we'll save that as being genotypes. We use function LSD test to run our Anova as genotype, and alpha is 0.05, which you see here the alpha is already set to 0.05. So if you didn't type in alpha, it would still be 0.05. So if it's already a default, you don't necessarily have to type it in. Run that. Check out our groups. Now we have a LSD test for our 5 cultivars. Now we can do the same thing for environment and look at our environments. So how about a biplot? So first we'll get the information necessary for the biplot using GGE. It's just a function within the GGE package. So we'll run GGE, save that as just a variable. We'll call it M. We're going to use our yield data. We want to predict yield given genotype by environment. So we have M. That's what M looks like. That's going to help us create our biplot. So we'll have biplot. We use M. We have our title. You can change colors, whatever you want. Pull up the documentation so you can see all these arguments. So not all these arguments are necessary, and some of them are default, so you can go through and read documentation and see what applies to you. So we'll run this biplot, and here we have a biplot. Zoom it in so you can see a little better. 5 cultivars in our 3 environments. This is a really nice, easy biplot. There's other packages that you can create a biplot in. I encourage you to go out and look for other packages that do the same thing. Never know too much. So now I want to move on to graphics. So I'm going to abandon our yield data set here and use a data set that comes preloaded with R in data sets. So we'll actually open that data set package. So library help equals data sets. So within R, it comes with a lot of data sets. So this is great if you want to practice on something, practice coding, and you don't have a great data set. Well, you can go into the R data sets and pull out a data set if you can't find one. So you can see all these different data sets. We're going to use Iris. So I'll type data Iris, and then I'll view the summary of Iris. So within Iris, we have columns sepal length, sepal width, petal length, petal width, and species. We can view the head, see how that's laid out. We can also open Iris over here and see how this is laid out. So you have continuous measurements in the first 4 columns, and then the species name in the last column. So now you'll want to install the package ggplot2. I already have this installed, so I'll just pull that into my library. So full documentation, we can check here. You can definitely check these out. I'm just going to cover some of these. So ggplot2 is a really great package for making visuals because it's extremely customizable, so you can make really beautiful graphics for publications and presentations. So first I want to show you a scatter plot, and I'll cover how to make a ggplot here. So you'll call ggplot, this is your main function, ggplot. You'll call the data, so Iris as we have saved it, and then you need the aesthetics function. So for this scatter plot, you'll need X, which is our sepal length, Y, our sepal width, and then I also want to use color and shape, and I want to do those by species. So what this is saying is that each species will be represented by a different color, and also each species will be represented by a different shape. So you'll do plus, and this is where you'll call what graph exactly you want to use. So geoPoint creates a scatter plot. So since I've already called my aesthetics up here, I don't need to call them in geoPoint. However, you can move some of these aesthetics into geom point, like your color and shape. And then I've added an X label plus a Y label plus a title plus this line of code which centers the title over the graph. ggplot by default left align the title, so this line just centers your title. So I'll run that, and you can see here our plot. So each species over here is represented by a different color, our color, and a different shape, our shape. So another great add-on to this graph is called a facet wrap. So everything's exactly the same. It's a scatter plot. All I've done here is done plus facet wrap by species. So now that segments the graph by species, it creates a little cleaner presentation. So just depending on your data and how you want to present it, this is also an option. Next, do a box plot. So again, we call ggplot, iris, aesthetics. This time our X is species and our Y is sepal length. And I'm going to call fill by species. Plus, and then geom box plot, X label, Y label, plot title. Now I've added theme dark. So I'll show you what that looks like. Also our center alignment of the title. Run that. Now we have a box plot. So I'll show you what this theme does. So there's a few different themes. We change this to theme BW. And it'll change the color theme of the background. So next, I'll show you a histogram. ggplot again, using iris data aesthetics. Keep in mind that given your graph, you may only be able to have a Y and not an X and Y, so keep that in mind. So again, I'll use color and fill given species plus our geom histogram. You can see here I've added position, identity, alpha 0.05, and a bin width. So position just changes the location of the bar, and I'll show you that. And alpha is basically the opacity of the bar. And bin width, size of the bin, X label, Y label, plot title, plot centering. So we'll run that. So what identity has done has overlapped the bar graphs. So you can see some of these overlapping. If we exclude this line of code, the default is not identity. So instead of overlapping, it stops and starts a new graph. Compared to here, we can see these two bars overlap. In default, they're actually stacked. So additionally, you can actually do dodge, given however you want to present your data, and that will align the bars next to each other. Or we can just get rid of that and add our favorite facet wrap by species. So that's another way to present the data. So as you can see, ggplot is very flexible. You can do a lot of different things with the same data in the same type of graph. So another one is a density plot. We're using iris, aesthetic, Our Y is our sepal length. We'll do fill by species. And alpha, 0.05. Remember that's our opacity or our transparency. X label, Y label. So we'll run that. You can see there have different species. And so I'll wrap it up with that. So ggplot is a really large package that has a ton of functionality and a ton of customization that you can make to your graphs. Also, these aren't the only colors you can use. ggplot comes with a lot of preloaded colors. You can search those. There's a number of colors, so you can make graphs as custom as you want.